I got sad news, guys. So I spent a whole week going down a bit of a rabbit hole. And I would say for the most part, what I have to show for it is the PowerPoint that I'm going to be presenting to you. I said I would show you what I do and what it costs, and I'd show you when it doesn't work. So it is what it is. It's interesting, but don't get your hopes up for this week. All right, let's jump into this little PowerPoint. Okay, core problem we're trying to solve here is one of the most common tools that that any of the AI coding systems will execute is where it's swapping one line of text for another. So edit or write, depends on what the AI coder wants to call it. So you can imagine very, very simplistic piece of code here. It's trying to edit a line that says x equal 1. But it turns out, for whatever reason, that line now says x equals 0. It'll just replace that line. Sorry, it'll attempt to replace that line and just fail because the string it was looking for doesn't match. And it doesn't really understand what went wrong, right? So if you have drift, it's going to fail to do edits. As you can see here, the typical tool, edit, file, old string, new string. So x equal 1, I want you to say x equal 2. Yay. All right. So here's what gets exciting. No. No. This is just deep coding stuff. All right. So there's a concept in coding called hash codes. I mean, it probably predates coding. It's pretty simplistic math. You take a string, convert it to a bunch of numbers, you do a bunch of XORs and stuff on it, and out pops a hash code. The hash code is one that anyone else can take the same string, do that, and generate the exact same hash code. So you can tell if the hash code matches your string or not. So it's a simple way to do, did the content change or not? Okay. If you downloaded random things, you'll sometimes see MD5 hash strings. So you can do check to see if the binary is correct. That's what this is. All right. So in this scenario, we can see that the edit tool changes the syntax. So instead of it being old new, it's now anchor new. And the anchor is line number, hash code. Okay. So the hash is now a contract. It's a little bit more clear. It actually reduces total token counts you have to send because you can do ranges and hash code and stuff. So it's a cool concept. All right. So similar kind of example. You try and edit. The anchor says 42A3. It fails because the hash code's now different because string changed. It's like, fine. The agent says, cool. Let me just change it again into 42B7. In this same, it gives the model an opportunity to determine if it just wants to reread that one line or whatever it wants to do. And then it reports, yeah, now the hash code matches. I'll let you change that string. So does this idea actually work? And if you saw the beginning of the video, I think you kind of know the answer. It's kind of meh. Well, let's jump into the results. Let's skip this explanation. All right. So here you go. On the lower end models, step 3.5, it is actually beneficial. So there's been some really cool papers where people go through this technique and brag about how great it is. It is under the right circumstances, and the right circumstances are probably 2 years ago. Well, not that long, about a year ago was the right circumstance. The models nowadays, they're just so far beyond this. It basically starts hurting on the DeepSeek model. I'm going to leave it in because if you look, I have off, optional, and only. So when we put in the only mode, it actually can be negative. But in the optional mode, you're just giving the model a choice to use hash codes or not. And it doesn't really hurt anything. It shouldn't drastically increase token pricing or anything. So I'm going to keep it, but underwhelming. This is definitely not going to get me to beat Opus. So I can promise you, I found one solution that doesn't work. All right. Well, keep them being ugly. Let's see what happens next week. I'm looking forward to it.